All right, here's a practice on piecewise. Now, you know that a piecewise is made up of two or more functions. Those are called pieces. And then each has its own domain. The real key, first of all, understanding how to evaluate, and then knowing how to graph. We'll do that. So the key is knowing the domain restriction. So -5 belongs to what piece? Well, because -5 is smaller than -3, it belongs to the top. So you only plug it into the top. So where there's an x, take it out, put in -5, and then you evaluate it. So -5, take away 5 is -10. The absolute value of -10 is +10, so the answer is 20. 2. So in which piece does 2 belong? So 2 is between -3 and 7, so it only belongs to the middle piece. So take out x and put in 2, and then evaluate it. So the answer is 4. 7. What piece does 7 belong? Well, it's close because they both have a 7 in the domain, but which one has a line under it where 7 is included? Here it's a whole. So 7 is included in the bottom piece. So it's the square root of 2 times 7 plus 6. So that's the square root of 20. Let's try that again. Can you evaluate? Know which piece you're plugging into. So for -3, where does it belong? -3 belongs in the middle. And for that, no matter what answer you put in, the answer is always 8. So the answer is 8. For -8, what piece does it belong to? That's the top piece because it's smaller than -4. So where there's x, plug in -8 and then solve it. So that's 256, and it's -256? No, -512. None. Getting ahead of myself. That's a 12. All right, again, -1/2. That's 512. Half of 512 is 256. So it's -256 plus 7. That's what makes -249. 3.1. That goes, where does that belong? To the bottom piece, because 3.1 is bigger than -2. What do those double bars mean? So it's the greatest integer less than or equal to what's inside. So we go back ultimately. So when I see these double bars and I subtract, and you can make them double brackets, I get -0.9. So what's the greatest integer less than or equal to that? So that answer is -1 is the greatest integer that's smaller than -0.9. All right, now let's get to knowing how to graph them. So again, for the graph, the key is understanding the domain restriction and graphing each to the domain restriction, not going beyond it. So understand this function on top is absolute value. It's going to look like a V. And then for the bottom piece, it's going to be a line. So let's graph it first. Let's start with 0. For the top piece, when you plug in 0, it's going to be a hole there because there's no line underneath the arrow. So when I plug in 0, I get the answer. Let me see where I'll put down the point. I'll put the points here. So I plug in 0, and I get the answer 3, and then take away 1, it gives me 2. So it's actually 0 and 2. So it's 0 and 2 is going to be a hole, and that's on the far right. Now the picture goes to the left. Now one thing I got to be worried about for a absolute value function is where the vertex is. So I don't want to just draw a straight line going left. I'm going to plug in more numbers. So if I plug in -1, what does that give me? 2 take away 1, which is 1. And then let me just pause here for 1 second.